Should we begin? All right. Good afternoon. First of all, thank you for coming. And today, we're going to have 3 lessons about the C operators, various functions, and some part of the decision making. Then let's begin from these C operators. So, actually, very good example of the operator is plus sign and negative sign. This is very common arithmetic operators. So C program uses those symbols for the operations. Then these C operators, the symbol to instruct the C to perform some specific action on the one or more object. So if you have plus sign, you're going to add 2 numbers, right? Then these 2 numbers are object and also known as operands. And plus defines the action you're going to do, which is the addition. So there are many kind of operators. So assignment operators. Actually, it is very simple. If you want to assign certain value to the variable, you're going to use these operators. Arithmetic, quite straightforward. Plus, minus, multiplication, division, something like that. And cast operators and increment, decrement will be introduced at the end of this lesson. And the other operators will be handled in the decision making and the other course. Okay, let's begin from these assignment operators, which is very simple, equal sign. So, let's say now you have a variable number, and then you want to define the value of the number inside of the C program. Okay, let's say 5. Then, what do you say? Number equals 5, semicolon, in your code, right? Then, this 5 will be assigned, this value will be assigned to variable number. So, yes, then you will use this equal sign to assign certain value. So this is called as assignment operators. So, okay, now, so in this example, we have 2 integers, a equals 2, b equals 3. We already used this operator, assignment operator, right? Then these a and b's are declared as integer. So you have these 2 memories for a and b. By this assignment, 2 is stored in the memory for a, and 3 is stored in the memory for b. Next, you want to do certain operation right here. A equals a plus b. So this a plus b will be assigned to variable a. So in this memory for a, you will store 5. B doesn't have any change, right? Okay, for this assignment operator, most important part is always the right-hand side is assigned to left-hand side. So you cannot have any operation on the left-hand side. Please remember that. Next, arithmetic operators. So I'm going to introduce not 4, 5 operators, plus minus, multiplication, and division, and the last one, percent. This is a modulus to return the remainder. Actually, we already used it in the first week of the lecture to distinguish even or odd number. Okay, then if you have 2 plus 3, these 2 and 3s are operands. So these are the object handled by this operator. And plus is binary operator. Why is it binary? Because this plus operator requires 2 operands. Then if you require just 1 operand, it is called as unary operator. Okay, then you already know about these 4 kind of arithmetic operations. So let me introduce this modulus, percent. Sometimes it is called as remainder operator. Yes, this operator used with integer values. Then once you have a division, then you're going to have the remainder instead of returning the float point number. So if you have 5% 2, then yes, remainder is 1, right? So return value is 1. So I'm going to show you how this remainder is useful in the later of this class, especially when we practice generation of the random numbers. Okay, so this is one example. Actually, we already practiced this. So this is the pseudocode to check whether an integer is even or odd number. So in input number, so you're going to obtain the value of the number from the user. And then if num%2 equals to 0, so which means this integer number is divisible by 2, right? So remainder is 0. Then you can say this is even number. Otherwise, else, yeah, actually another possible result is num%2 is 1, right? Then it is odd number. So let me show you how to demonstrate this code, this pseudocode to the C program. Okay, first of all, so always don't forget starting. Oh, thank you. Always start from hash include and stdio.h to load the header file. Then int main void and define the range of the main function. Okay, first of all, so in this slide, I'm going to just follow this pseudocode. Input num. So I want to define the variable, which is integer, name is num, right? Okay, then we want to obtain this value from the user. Then always think about the pair of printf and scanf. Printf, enter an integer. Let's say like this, and semicolon. Scanf, and specifier for integer is %d. Then and num. So always remember to add this and symbol in front of the variable name when you use scanf function. Okay, then now we obtained the value of num from the user. Then if num%2 equals to 0, I'm going to explain about this dual equal sign later. And then, if num%2 is 0, then what do you do? Define the range for this if section. Then printf the input number %d is even. Change the line. Then in this %d specifier, you want to display the value of variable num. Okay, that's it. Then else. Else means num%2 is 1. Then printf the input number %d is odd. Change the line, comma, num. Okay, and then to end the program, return 0. That's it. Oh, there's a typo. Return 0. Alright, then let's build the program. Then run this. Okay, can you see this prompt here? Enter an integer, right? Then 5. Then you can display the input number 5 is odd. So this is how you can use this %. Just for fun. Okay, actually you can, let's add another printf. The output of num%d, actually twice. %d is %d. Change the line. Then in here, I want to display num%2. You can do the operation here, right? So if the number is even number, this value is 0. If num is odd number, this is 1, right? Okay, then you can display this outcome value in this specifier, the location of the specifier. Okay. So enter an integer here. Then let's say 8 is even number. Then you can display this. The output of num%2 is 0. Right? So because the remainder is 0. Okay, then let's switch the screen. Then let's move on to the typecasting, cast operation. So now, let's suppose that we have integer variable inum and double dnum right here. Then you're going to do the operation like inum divided by dnum. Or you can have inum times dnum, such operation. And then if you have this mixed mode calculation of the different data type, in this example, integer and double, then this inum is promoted to type double in this calculation. But remember that the variable itself remained as integer. So this is the example. if you have I num divided by d num, then now I num is 1, d num is 2.0. Then outcome is 0.5. Okay, then what if you have integer divided by integer? Then outcome must be integer, right? Okay, then number 1 is 5 and number 2 is 2. Then now you have number 1 divided by number 2. Now what is the actual value? 5 divided by 2, it must be 2.5, right? But since this is integer divided by integer, you can only store the integer value. So the decimal place will be dropped out. So if you have 5 divided by 2, then actual outcome will be 2, not 2.5. When you have integer divided by integer. Okay, then now, number 1 is 5, still integer. Number 2 is 2.0. 2.0 means type double. Then now you have number 1 divided by number 2. 5 divided by 2.0. Then outcome is 2.5. Outcome can be type double instead of integer because integer is promoted to type double. So this promotion has an order right here. So okay, when you have operation between character and double, character becomes double. When you have the operation of float type and double type, then float is promoted to double. Actually, you won't see the much difference though. Okay, so this is the example, another example. So this conversion by assignment. So in the previous slide we had operation, but now we have variable d num type is double, I num is integer. Then we assigned value 5 to I num, and we have assignment right here. So d num equals I num. So you put the integer value 5 to d num, right? Then this value is also promoted to the double type double. So you can store 5.0 as a double number. There's no loss of the precision. Okay, then now opposite case. Let's suppose that d num is 5.8. And then now we want to assign this type double number to variable I num, which is integer. Then what's happening is this integer only can store the integer value, not the decimal place. So instead of 5.8, only 5 will be stored in this integer variable. Okay, then sometimes you can intentionally change the type of the variable. It is called as typecast. So now we have I num, type is integer. Then if you say parenthesis float I num, then type of this I num switches to float type. Of course, if you say double, it is switched to type double. So example is here. Now we have x equals 7, y equals y. Both are integer value. Then now you have an operation of x divided by y, which is 7 divided by 5. What is the value of 7 divided by 5? 1.4. All right. Yes, 1.4. But this is integer divided by integer. So don't be confused. This is very important. Integer divided by integer, then the return value should be integer as well. Okay, then let me ask you again. Now they are all integer. 7 divided by 5 is 1. Right? So you can preserve only integer values. But now, you have a typecasting. Double x divided by y. So it is equivalent to 7.0 divided by 5. So now, you can have float point number as a result. Then outcome is 1.4 because of this typecasting. Okay, the opposite order is also working. X divided by double y. So, in the first case, this is double divided by integer. Second case is integer divided by double. They are all same. So the integer is promoted to type double. Then you can have this result. Okay, next. Arithmetic assignment operators. So you learned about the assignment operator, which is equal sign to assign certain value. Next, arithmetic operators, quite straightforward. Plus, minus, multiplication, division. Then you can do both operations at once. So plus equal, slash equal, percent equal, something like that. Okay, then this is the initial full statement. A equals A plus B. And then, so let's assume that A is 1, B is 2. Then this is a 1 plus 2. Then A will take the value of 3. Then it is shortened by using these arithmetic assignment operators. So you can use A plus equal B. It is equivalent to A equals A plus B. So you can use the other arithmetic operators combined with this equal sign. So A plus equal B is equivalent to A equals A plus B. A minus equal B is A minus B. Something like this. Okay, then now you have certain operation on the right-hand side. And then you can assume that there is parenthesis, which means you're going to complete these operations on the right-hand side. And then after that, you will have a certain operations, in this case, division. If you have A percent equal B plus C, it is A percent, parenthesis, B plus C. All right, any question for this assignment, arithmetic assignment operator? Confusing? Yeah, it is just to shorten the length of the the statement. So if you are confused about it, actually you can. It is okay to use this full statement. Either way is fine. Next operator is similar. So this is just to increase and decrease the value. So it is plus sign, minus sign. So it is to add or subtract 1 to the variables. Okay, then now let's say we have a variable c. Then the value of c is 5. Then you want to add 1. And you want to make c 6. Then, first of all, you can say c equals c plus 1. Yeah, it's quite straightforward. And then you just learned the arithmetic assignment operator. You can also say c plus equal 1. But only for adding 1, you can use c plus plus. Then if you have c minus minus, you will subtract 1 from the original value. Okay, but there is the different meaning depending on the location of these operators. Can you distinguish the difference of them? So sometimes these operators comes after the variable, right? But sometimes operator is ahead of the variable. So when the operator comes after the variable, it is called as post-increment or post-decrement. If the operators appeared ahead of the variable, it is called as pre-increment or pre-decrement. So this post and pre operator has a different action. So let me give you an example. Let's suppose that c equals 1. And then we want to assign minus c to the variable result. So this is pre-decrement. What's the meaning of it? Pre-decrement means subtract 1 from this variable and then use it. So you may not catch what the meaning of it. So now c was 1, then c becomes 0, then this 0 will be assigned to variable result. So now result is 0. Then c equals 0, result equals 0. So it is equivalent to these two statements. C equals c minus 1. So c becomes 0, and then result equals c. Okay, so if I explain this post-decrement, you can distinguish the difference of them. Now we have a c. The value is 1, same with the previous one, right? Okay, then you have result equals c minus minus. If you have post-decrement, you're going to use the current value of the c. Then after that, you will decrease the value of it. Okay, then let me give you a more specific example. Now, since you have a post-decrement, c is 1, then the 1 is assigned to variable result. And after that, you decrease value of the C. So eventually, C is 0 and result is 1. Okay, then let me write the full statement of it. If you have result equals C minus minus post decrement, it is equivalent to result equals C, which means assign the value first, and after that, decrease the value of C. Can you find the difference with the pre-decrement? So for the post-decrement, assign the value and decrease the value of it. But if you have post-decrement, decrease the value first and then use it for the assignment. So that's why these two operators make a different result. Okay, then this is the table of this post and pre-increment and decrement. Let's say the initial value of C is 1 for all the case. If you have a C++, this is the post-increment, then after the operation, C becomes 2, but you're going to use original value, 1. Then if you have plus C, pre-increment, C is 2, then you will use this increased value 2. Decrement is same. C minus minus, this is the post-decrement. So use 1 first, and then C is decreased to 0. If you have pre-decrement, decrease it first, and then use it. Any question about these 4 kind of operator, pre and post? Okay, so then I'm going to try this example. Okay, let's see. Okay, in this code, we're going to try this pre and post increment. All right, so in this main function, first we have variable C. C equals 1. This is the initial value of the C. Then you will display this. Okay, the first line, C equals %D, then C. You will display value of C, which is 1. Then C++, you will display C++. What do you display in this statement? 1, 2, not interested? 2? Okay. So this is the post increment, which means use the current value, and after that, increase it. What is the current value in this statement? C is 1, right? Then display 1. After that, C becomes 2. Then this line, after C++, you want to display value of C. What do you display? 2. C is increased to 2. Okay, then now you want to display plus C, pre-increment. Increase it first and then use it. So, if you add 1, what's the value of C? 3. And then you will display 3. Then after this, C is 3. Right? Okay, then let's try this. I'm going to make it as a comment, the other part. Then we're going to learn only this part. So, in this line 7, you display C equals 1. And then, line 8, you still display 1. Because this is post-increment. And after C++, C becomes 2. Right here. And then, you have pre-increment of C. So C becomes 3, and then you will display this value right here. Then after this operation, C is 3. Okay, then let's try another example. Okay, let's try to read this part. Now, C is 3, Y is 5 plus C plus plus. Then you will display value of Y. And then you will display value of C. Okay, is it pre-increment or post-increment? Post. Right? Then, in this operation, what value do you use? 3 or 4? 3. The current value is 3. Then, what is the value of Y? 5 plus 3. So, which is 8. So, you will display 8 in here. And then, what is the value of C after this operation? It becomes 9. Okay, do you want me to change it to Y++? No, yeah. Yes, C++. So C becomes 4. All right, next case. Next case is pre-increment. C is 3 again. Y is 5 plus C. Increase first and use it. So it is 5 plus 4. Yes, Y is 9, C is 4. Okay, from this line 15, Y is 8 because you have post-increment. Then C becomes 4. If you have pre-increment, Y is 9 and C is 4. Can you find that the difference of pre and post operator? Okay, good. Then let's move on. So we already demonstrated this in the code block. Okay, so when you have these operations, there is a precedence. Actually, you already know about it. You can feel it because you have used it for a long time from your primary school. If you have plus and addition and multiplication, which one has priority? Multiplication, right? Multiplication and division are in the same level. Then left one has priority. Right? Okay, then if you have parentheses, this one has priority. So you already have sense of it. So this C program also follows that. For example, if you have A plus B over C, you're going to do this first, B over C. And then, of course, if you have parentheses, it has priority. So this is the order of the precedence. Then, okay, I just want you can follow your sense, but sometimes it's going to be confused. Then, of course, during the quiz, so we're going to provide this table. So don't be scared of this complicated one. Okay, then let me give you an example. Actually, percent and asterisk multiplication has the same precedence level, which means you're going to do this first. 15%, 6. What is the remainder of it? 3, right? Then eventually it becomes 3 times 2. Then it becomes 6. So, to make it clear, yeah, of course you can add this parenthesis. It is also acceptable. Sometimes the right associative has the priority on the right-hand side. So, this is quite confusing. X equals Y plus equal Z minus equal 4. There are so many assignment operations. If you have assignment operations, right-hand side has priority. So you're going to do this first. So now Z minus equal 4, then you're going to do these operations. And then next, you will do this operation. For better, okay, so this is the example. Now, Y equals 0, Z equals 0. Then what's going to be the value of X? And then, you're going to do this first, Z minus equal 4. Then, Z becomes negative 4. Because initial value of Z is 0. So now Z is negative 4. Then you're going to have Y plus equal negative 4. So since the original value of Y is 0, this operation gives negative 4. So eventually, the value of X is negative 4. Okay. Then next example. We have the 3 variable X, Y, Z, and they are all 5 integers. Then you have these operations. X percent equal Y plus Z. Since this is the assignment operator, you need to complete the right-hand side first. Y plus Z, 5 plus 5, which is 10. And then you're going to have X percent equal, which is 5% 10. So X percent equals parenthesis y plus z, which is 10. Then you're going to have 5% 10. So remainder is 5. Okay, then for the summary, so you learned about the various operators starting from the assignment, equal sign. So for the assignment, most important part is right-hand side is assigned to the left-hand side. So you cannot have operation on the left-hand side. Then, all right. So for the increment and decrement, so you need to distinguish the difference of them. If you have post-increment, use the value, and after that increase it. If you have pre-increment, increase it first, and then use it. So remember this difference. All right, that's all for the operators. Oops. Then let's learn about the standard library functions. So functions are so-called as building block of the C programs. So like printf, scanf, sqrt, sine, cosine, something like that. So, code block provides the various package of the functions known as the C standard library, and then those functions are making a bundle of the header files depending on their usage. So you already know about this stdio.h header files, standard, input, output. So this header file contains the prototypes of the functions in the library, macros, and so basically this header file contains the basic functions. Then there are various header files. ctype.h, this ctype header file contains the character handling. So it evaluates whether the characters are alphabet or number, or it switches the lowercase to uppercase or the opposite direction. So you already used the math.h. It contains a lot of math functions like a sine, cosine, exp, log, sqrt, square root, right? stdio, this is a basic header file. Every time when you write your C program, you'll start to loading this stdio. And the standard library functions contains the miscellaneous functions, various. Especially this header file contains the random function, so to generate random number. So it will be used a lot in this class. And string handles strings. Time has functions about the time functions, like displaying the current time, something like that. Or you can hold the operation of the program for a while, like a sleeping. So this is the list of the functions in the math.h, but they are not all. So actually it contains a lot of functions. So you can find the cosine, sine, exp, log, power, square root, sale, floor, something like that. Then, how can you use these various standard functions? You need to know the name. You need to know the name of the function. So what is the function name to obtain the input from the user? scanf. Right? Do you remember that? Scanf function is to obtain the value from the user. Yeah, so you need to know the name of it. And also, you need to know what that function is doing. Then, so to utilize those functions, you need to know the input argument. For example, now you want to use sine function. What's going to be the input? First of all, you need to know how many input you need, and also what type of the input. Sine function requires the numeric number, right? Then how many? Just one, right? What about POW function? Okay, maybe you are not familiar of it. So POW function is doing the power. So it requires two numeric input. If I say POW 10,2, then it is 10 to the power of 2. If I say POW 2,3, 2 to the power of 3, which is 8. So it requires two input, not only the integer. Then you also need to know the output result. Yeah, so now I just gave you the example about the mathematical functions. So always the outcome is numeric numbers. But some functions doesn't have a return value, outcome. For example, printf. This part is quite confusing. Printf function actually show you the result on the screen, right? But inside of the program, it doesn't store any value in the memory. Its function is to display something on the monitor. So we usually say this printf function doesn't return any value. So it is called as void function, no return at all. Mathematical function returns numeric values, right? And some function returns only 1 or 0, true or false, something like that. Okay, the last one. You also need to know which header file contains those functions that you want to use. So, it's difficult to know every functions used defined in this C program. So, yeah, if necessary, once you begin your coding, actually you can also do the web surfing to search those functions. Okay, stdio, it has a lot of functions about the input and output. This printf, yes, you already use a lot, right? Then what about putchar? Putchar means you can display one character on the screen. For example, putchar, parentheses, and single quotation mark uppercase A. Then you will display uppercase A on your screen. Actually, you can use printf function to display uppercase A as well. Right? Then scanf is to obtain the value from the user. Getchar is the opposite of putchar. You can get one character from the user. Okay, then flush. So when you enter certain value using the scanf or getchar, so basically, so you're gonna hit the keyboard, right? And you will hit the enter. So those inputs are stored in the buffer memory of the computer, and eventually those values are assigned in the variable one by one. Then, I'm going to explain about this in the later slide, but so even hit enter is considered as one of input, then this enter value is stored in the buffer memory. So if you request to enter the 2 characters in a row, then let's say you enter A, and then you hit enter, then in the next request, you hit B and hit the enter. Then actual input is A and enter, not B. So in that case, you need to delete the enter value stored in the buffer memory. So then you can use this F logic. I'm going to explain more detail with the example in the later slide. Okay, then I'd better start from this scanf. Because you already learned about how to use printf. So using the specifier, and also you can use some operations after comma. Then, so when using this %c is the specifier for the character. So this is to read the characters. Then you need this white space, like a space, tab, new lines. They are also considered as character. So for example, this is a scanf. Then, okay, look carefully. So this is the statement. And you can find there are 2 specifiers, %c, %c, which means you want to obtain 2 characters in a row. And then you have comma and ch1, comma and ch2. That means the first character will be stored in ch1. Second character will be stored in ch2. So if you have this statement, you may key in AB. And then ch1 takes A, ch2 takes B. But just you wanted to separate them, so you enter A space B using the keyboard. So in that case, ch1 takes A, but this ch2 takes space character, not B. What about the numeric numbers? Numeric numbers are okay. You can add the space, although you have %d in the scanf. So let me show you the example. All right, now we have this code. We have 2 variables, ch1, ch2 for character. Then you prompt the user to enter the letters, and you have a scanf, 2% and ch1, ch2. Then after that, you will display the value, letter in ch1 and ch2. Okay, then let's demonstrate this one first. All right, now you are asked to enter letters, actually 2 letters, then let's say A, D. Then hit the enter. Then, yes, as you expected, letter 1 is A, letter 2 is B. But if you add space, A, space, B, can you distinguish the difference? Okay, hit the enter. Then letter 1 is A, letter 2 is space, not B. Because space is considered as a one character. So, in this case, you can just type the letters in a row without any space. Sometimes you can add space between these specifiers. So look carefully. In this line 7, you can add space. %C, space, %C. Then let's see what happens. Now, I'm going to enter letter A, space, B. And then you have A and B when you add space here. Okay, then let's add one more space. Let's see what happens. And then I'm going to add A space B, only one space. Yes, you still have B. Because now, once you give the space between these 2 specifiers, then you can add space between these 2 letters. Then this space input is ignored. All right, then let's move on to this numeric number case. Now, you have num1 and num2, they are integer. Then, in the scanf function, you have 2 specifier, %D, %D. Then you will display num1 and num2. Okay, I want to assign the value 1 and 2, which is quite simple. Then, and why is it considered as error? Maybe add space. Okay, enter the 2 numbers, and then 1, then let's say 2. Isn't it strange? This is 12. So you must give the space, right? Then you can assign 1 and 2 to number 1. But, so depending on this IDE, the absence of the space is allowed or not allowed, but it seems that my IDE VS Code doesn't allow the absence of space between this %D and %D. So that's why, now it's working. Okay, enter number 2 numbers. Then if I say 12, 1 and 2 without space, it is considered as input 12. That's the characteristic of the numeric number. Then this scanf is waiting for another input, like this. So then 1, 2 is assigned to number 1, 2, 3. 23 is assigned to number 2. So for the input of the numeric numbers in a row, you need to add space. Or, as we demonstrated, if you just give the input of the one number and hit the enter, then this scanf function will wait for the second input right here. Like this. Okay, then so this is another case. When reading the numeric data, if you type two numbers, then only the first number will be assigned in this variable, and then the next input is will be stored in the memory buffer memory. So if you add a space, this 123 is considered as a separated number. So there are two numbers. But if you have a single %d specifier in the scanf, this 456 is considered as a second number, so only 123 will be stored in variable A. Then what about this 1, 2, 3, X, Y, Z? So only this 1, 2, 3 is recognized as a numerical value. So 1, 2, 3 will be stored in A. Then X, Y, Z input will be remained in the buffer memory. So if you only enter 1, 2, 3, then yes, the 1, 2, 3 will be stored in A. Then this enter input will be remained in the buffer memory. So, but if you request input of the numeric value in the next scanf, this enter input will be ignored. But the problem is when you request the input of the letter, because this input of the enter value is considered as one single letter. Then it is stored in the buffer memory. So before you enter any other letters, this scanf function will use already stored enter value in the buffer memory. So that's the problem. Okay, then how can you do this? So once you enter the numeric value, you hit enter. Then if you say f flush stdin, so this is the grammar of this function, then you will remove enter input in the buffer memory. And then eventually you can use this scanf to obtain the letter value. Okay, then, sorry? %C. Combine. I haven't tried to combine different type of the variable. Why don't you try it at home? Let's see. Oh, wait. Why don't you try here? That's a very good question. Alright, so this is the modified code. We have num2 as integer. We have ch1 as character. Then, in the scanf, as you asked, we have %c and %d. I also wonder what would happen. Then, the first variable is ch1, which is character. num2 is integer. Then after that, I'm going to display value of %c, ch1, and %d, num2. Making sense? Okay. Error. I already declared the variable here. So let's delete it. Okay, now it is working. Then run the code. Please, let's ignore this message. Then, now we have to enter one letter and one number, integer number, right? Then let's say A, 1, 2, 3. Then we hope that A is stored in ch1, 123 is stored in number 2, right? Okay, hit enter. Alright, it's working. Okay, very good. What if we switch the order of it? %d and %c. And num1, ch1. Then input has to be 1 to 3a, right? Numeric number first, because this is %d and %c. And then letter 1 to 3, a. Okay, it is also working. Oh, don't be confused. I displayed the ch1 first and num1 first. Okay, good. Yeah, I learned from you. Thank you. Yeah, you can mix it. Okay, then next. Let's try this. Alright, now we have integer num and ch, the character ch, two variables. And then first, you have an input of %d. And then as I mentioned, once you enter the number, you're going to hit enter key. That one is stored in the buffer memory. And after that, you have scanf for the character, ch, %c. Then, let's see how the values are stored. So first, I'm going to add the number, let's say 1, 2, 3. And then I'm going to hit enter key. Then look carefully what happens. So, if the program is normal, once you enter this number, then you will display enter the letter, right? And then it will wait for our input of the letter. Program is done. Why? Okay, so in here, I entered 1, 2, 3, and then hit the enter key. Then, you display this message, enter the letter. Right here, this one. So, this statement, line 10, worked. And after that, it seems like you skipped this, and then you displayed number is 1, 2, 3 from this line 13. And then letter is Can you recognize that? Letter is, there's nothing, but there is period. So, letter is %C, period. So, enter input is stored in this CH. So that's why you change the line and then displayed this period. Okay, so that's the problem. So let me give you another example. Let's say we have a num and num2. Two integers, and then I want to change this one as %D and num2. So we want to obtain the second integer value. Then I'm going to display %D num2. Then, okay, first 1, 2, 3, then enter the letter, but I didn't change this sentence. Right? So now this scanf in line 11 is waiting for my input in the program. So let's say 3, 2, 1. Then you display 1, 2, 3, 3, 2, 1. So when you use multiple scanf functions, the numeric numbers are okay. They don't care about the enter input stored in the buffer memory, because it is not numeric number. But if you request character input, then this enter can affect the result. So we want to use this flush stdin. Then, in this scanf, you will enter numeric number, then you're going to hit enter. Again, enter key is stored in the buffer memory. Then, this flush function will delete it. So, memory is empty now, no input at all. Then, you have this another scanf. And it will wait for your input, because memory it doesn't have any input. Okay, enter the number 1, 2, 3. Then I'm going to hit enter. Okay, it is not working, right? Buffer memory is not deleted. Let me tell you why. Actually, this is the problem of the Mac system. So if you try this flush in the code block in the lab, working on the Windows system, yes, it will wait for the input of your character. But in the Mac, yes, flush is not working. So, don't know why. Actually, the Mac has a different function, but I won't cover about that. Yes. So this is the failed demonstration. Okay. Then, to obtain the letter, character, single character, then you can use get char as well. And then, so when you use get char, it stores only the one single character. So if you have the multiple input, as you can see here, when you call the get char function, you key in ABCD instead of just A. Then only A will be used. Then these 4 input will be stored in the buffer memory. So getcha will store only A, the first letter, then the other one will be stored in the memory. Okay, so in that case, you also need this flush, stdin, to delete all the memory. All right. Then, let me introduce the couple of useful functions about the mathematics. So first one is FABS. So this is to obtain the absolute value of the float point number. Actually, we have a function ABS as well. That name is more straightforward, right? ABS function returns absolute value of integer. So remember, if you handle float point number like float type or double type, then you must use FABS, not ABS. Then trigonometric function, sine, cosine, tangent. So this function uses radians, not degrees. Exponential and log 10. Some hyperbolic functions. Power, as I introduced, it requires two input. SQLT, square root. Sail and floor. I think I can skip the example of the SQLT and power. POW is quite straightforward. And then let me talk about the sail and floor. So for these two functions, the concept is quite straightforward. So if you have a sail, then it will return the integer value after rounding up, right? Then if you have a floor function, it will round down the number and it will return the integer value. For example, now your input, this x is 1.4. Then if you have sail x, it's going to be 2.0. If you have floor 1.4 is going to be 1. So this is to rounding up and rounding down. But these two functions doesn't return integer value. It still returns the float point number, 2.0, 1.0. Okay, C-type. It handles the characters. Then most of function in C-type header is to check the status or character of the input. So the most of the name of the function in C-type is like asking. For example, is alpha? It is asking. Is it alphabet? Something like that. So if the input is alphabetic character, A, B, C, D, then this function will return true value, which is non-zero. If the input is 1, 2, 3, something like that, the numeric number, not alphabet letters, then it will return zero value. Zero means false. Is digit? It is also asking. Now you can catch what this function is doing. If input is numeric numbers, it returns 1. Otherwise, it returns 0. Is alum? Alum means alphabet and numeric. So combination of these two functions. And is lower, is upper. It evaluates whether the input alphabet is uppercase or lowercase. To lower, to upper. This is to switch the case from upper to lower, from lower to upper. So this is the example of the using is digit. Let's say now input is 1. This is the digit. Then it returns non-zero value. If the input is alphabet, it returns 0, which means false. Okay, for this example, where is it? Okay, now we have two headers, stdio, C type, and we have a character ch, which is 3. But notice that this is not numeric value 3. This is the letter 3. So that's why I have a single quotation marks right here. So the actual integer value of the ch is not 3. So if you go to the ASCII table, you can find the ASCII value of letter 3. I don't remember exactly. So then this ch will contain that integer value corresponding to the letter 3. Okay, then I'm not going to use this one. Then we want to evaluate whether this input value, letter 3, is digit or not digit. So, if is digit and every function uses this parenthesis pair, then you're going to do something inside of this parenthesis. So, this isDigit function requires one input. Then input is ch, which is the letter 3. If this letter 3 is digit, this function will return non-zero value. If it is non-digit, it will return 0. So, if this return value is not 0, this exclamation mark is opposite. Then you will display this sentence. ch is a digit. Else, ch is not a digit. Then outcome is 3 is a digit, right? Okay, what if you change this input? Let's say ch is lowercase a. Then you will display a is not a digit. Then let's check the return value of the isDigit function right here. Now, ch is lowercase a, and then, first of all, the return value of the isDigit ch is 0 from this %d. So, this function returns integer value. So you will display 0 here. And then let's change it as 3. Then can you find that? Return value of isDigit ch equals 1. You can also enter the actual character in here like this. isDigit single quotation mark h. So you're going to have 0, right? So return value of each digit is 0. So this is how you can use this each digit or each alarm, those functions. Any question? Huh? This one? I cannot hear you. This one. So, okay, then let me explain about this. So, now, this sentence is displayed by this line 8, right? Okay, then instead of the input of ch, so that was the previous code, and then instead of using this variable in here, I wanted to show you another example of using this function. So you can directly enter the character to evaluate it. So, but if you say just A, this is not the input of the character. You have to use single quotation mark. Then this H is the input of this function. Then H is not a digit, right? So this function returns 0 value. So you display 0 in here. So it is equivalent to CH equals H and CH. It is same. So did I answer for your question well? Okay, thank you. You need more clarification? Yeah. So for example, let's change this one. Can you follow my cursor? Like 5. And then the outcome is 1 because input is letter 5. Let me give you another example. If you just key in 5, what happens? Zero. It's going to be letter. But I don't know what letter it is. Because if you check the ASCII table, there should be certain letter assigned to integer value 5. So, actually, if I know the ASCII value of the numeric numbers, then it can be a very good example. Maybe 42. Let's say this is 42. We can do the test. Okay, now CH value is 42. Then it seems that 42 is assigned to asterisk, as you can see here. So this easy digit value function gives a 0. What's the ASCII value of the numeric number? Okay, then let's move on. So, ABS. ABS function is to find the absolute value, but it is for the integer, as I mentioned. And then system, so you can enter certain comment to handle the operation of the program. So for example, in the system function, if you enter the keyword pause, then you can stop the pause the operation. Then if you want to resume the program, hit any key. So you can add this kind of function. Okay, then I want to spend a little bit more time for this lend and slend function. So this is to generate random number. Yeah, actually the lend function generate random number. Then the range of the random number is from 0 to 32,767. So this is the possible maximum number when you generate random number using lend function. Okay, so this lend function is included in standard library header, stdlib. Then this is how you can generate random number. So let me show you in the code. So this lend function returns integer value between 0 and 32,000 something. So in this code, you only have this printf function. 3 random integers are 3% these specifiers. And then you have 3 random numbers. So the integer values in each function will be displayed in these %d specifiers. Of course, you need to load std library, standard library header. Okay, then let's run the program. Okay, can you find that? Yeah, actually in this slide, so I defined the range of the random number from 0 to 32,000, but it depends on the OS system and also the handling bit, like a 32-bit byte or 64-byte system, something like that. It has a different range of the random number, I think. So that's why, as you can see here, you have a much larger random number generated. So, okay, so this is the random number generation. And then, but the problem is, if I run this program again, multiple times, yeah, so actually my ID may not ideal to show this. This is the first run of the program. So look carefully and remember this. Of course, you cannot remember this. Okay, so this is the first random number set. This is the second. And this is the third run of the program. Actually, they are identical. That's what I'm going to tell you. So in this lend function, when you generate random number, it requires certain seed. Then from that seed, it generates certain random numbers. But if you don't provide any seeds, then you will generate this same set of the random numbers continuously. So in this case, we need to use slend function. So look carefully. So in here, this slend function, unsigned means the positive range, And time null function means it provides the seed with the current time in this computer. So when you run this program, every time current time is changed, which means you can provide different seed to the lend function. And then when I activate this statement using slend, let me show you how the result is changed. So I'm going to run this program 3 times. It's built. 1, 2, 3. So this is the first run. Second, third. Can you find that? Numbers are different each other? Yeah. So that's why you need to use this slend function. And this time null returns the current calendar time. So every time when you run the program, you can provide the different current time, right? Which means different seed. Okay. So from this time null function, you will provide unsigned integer to this slend function as a seed. So that means when you use lend function, every time you must use slend function. But in the one program, you use just slend function once, just before you use the lend function. Then after that, you can use lend function anywhere. Okay, then now you found that this lend function generate random number, but range is very wide. But sometimes you want to confine the range of the random number, right? Then this rand function will be useful. Okay, let me give you one simple example. You want to make a program rolling dice, 6-sided dice. What is the possible number of it? From 1 to 6. Then you will generate random number, right? Okay, then let me explain how you can define the range of the random number. Now you can utilize the modulation operator, remainder. Okay, in this example, now let's say you just use lend function. Then what's going to be the range? From 0 to very large number. Okay, then I used modulation. Let's say lend %2. Lend is integer value. Then now you have a %2. What is the possible outcome? Whatever integer value you have, if it is even, outcome is 0. If it is odd, outcome is 1. So, if you use %2, you will generate number from 0 to 1. There's only 2 possible outcomes. Whatever random number you have. Okay, now you learn how to confine the range of the random number using remainder. Okay, now we have a %3. Then what's going to be the range? 0, 1, 2. right? Only 3 numbers are possible. And then, now, you want to generate random number between 1 and 10. Then, do you use length percent 10? If you use percent 10, what is the range of the random number? 0 to 9. Not from 1 to 10, right? You cannot have a 10 as a remainder when you divide some number by 10. That doesn't make sense. Then, how can you make between 1 and 10? Percent 11? So now you have a 0 to 9. Then you want to have 1 to 10. Just one shift of the whole range. So, length percent 10 is between 0 and 9. Possible numbers are from 0 to 9. Now, add 1. Add 1, then range will be shifted to 1, between 1 and 10. $11? Okay, good point. Let's imagine now you have percent 11. Yeah, okay, then let's say now we have a percent 11. What is the possible remainder value? No, 0. This one? Here. White. Number 1. This one? 1. If you have percent 11, first of all, the possible number is from 0 to 10. Right? So, the number of the possible number is totally different. The range. Yeah, what? No, then you're going to have a 0 as well. How can you not consider that? Yes, 1 to 10. From 1 to 10. Yeah. Okay, then can you tell me again?
You said if you need to put plus 1, the front part need to change to 1, right?
Yeah, because you added 1 from 0.
So let's say if here is already 1, but this one we put percent 11 instead of plus 1, cannot.
What do you mean you already put 1 in here? So just forget everything, then now you have a length percent 11.
Okay.
Then what's going to be the range?
Is it still 0 to
10, yes.
Not 1 to 10, is it?
Okay, what if the random number is 22?
No, I understand the percent 10 is 0 to 9. But when you said you want number 1 to 10, you said here that after the percent 10 you must plus 1, correct? But the front part you change from 0 to 1.
Because you added 1.
So if let's say we add 2, here must be 2, is it?
Right. There's a 2-step shift. Then the range will be 2 to 11.
Understand.
Okay, good. Oh, this is the beauty of the small class. Okay, then I'm going to show you more comprehensive case in the next slide. Okay, wait. All right, then why don't you demonstrate this code? First, I want to provide the seed from the time using slend function, and then I want to generate 100 random numbers. So I'm going to run the loop. So the syntax of the loop will be covered in the next week lecture. But now I'm going to run the loop 100 times. Then, now the number is lend %90 plus 10. What is the meaning of it? Can you say the range of the random number in this case? 10 to 90, 99. Why? Okay, first of all, let's think only length %90. Then the range is from 0 to 89. Right? Then plus 10. 10 step shift. So the range is from 10 to 99. So my intention is to generate only 2-digit random numbers. Okay. Then I'm going to display this number and change line 100 times. Why? Only 2-digit numbers? It is easy to distinguish the range of the numbers when you have hundreds numbers. Okay, now I generated 100 random numbers, as you can see here. They are all 2-digit, right? Okay, then let's go back to the basic. Now I want to demonstrate 6-sided dice. Sorry. Okay, then I want to have %6. Then the number range will be from 0 to 5. But dices will give you number from 1 to 6. So I added 1. Then you can generate the number between 1 and 6 100 times. Okay, then let's then I'm going to show you another more comprehensive case. Then I'd better switch the slide. So this is how you can define the range of the random number. So we have, so you want to generate random number from minimum to maximum. So if the mean is 1, max is 6, then you will generate random number between 1 and 6. Then, how can you define this length function? This is, so actually, if you want, you can remember this. Length percent n plus mean. N means the number of the numbers. How many numbers you have in the range. For example, for the 6-sided dice, you want to generate number from 1 to 6. There are 6 kind of numbers, right? So this n has to be 6. Then what is the minimum number? 1. Add 1, right? Then sometimes you want to generate a number from some specific number like 10 to 99, for example. So in that case, what is n? 10 to 99. Then how many numbers do you have? 99 minus 10 plus 1, because you need to count 10 as well. Then 90, right? So n is 90, and minimum number is 10. So this is how you can define n. Max minus mean plus 1. To count mean itself. Okay, then let's go back to this IDE. So I want to demonstrate random number generation when the user input minimum number and maximum number. So always don't forget to load standard library and time function and declare the variable num, min, max, counter equals 1. So this counter is to run the loop. And then slength to seed the length function. And then you will ask user to enter the minimum number and maximum number. For example, if you enter 10 and 99, then that's going to be the range of the random number. Okay, then how can you define the random number range? So length percent max minus mean. So this is the user input plus 1, and then plus minimum value. Then display it. Okay, then let's run the code. So, what range of the number you want to generate? What? 20 to 60. Okay. Then this n value, this n is 41, right? Not 40. Don't be confused. Because, okay, so it is 60 minus 20, but you also need to count 20 itself. So this is 41. What is the minimum value? 20. All right. Then you can generate these numbers between between 20 and 60. Actually, I learned the loop how many times? 10 times. Yeah, so you can find that all the numbers between 20 and 60. Okay, so this is how you can define the range of the random numbers. Okay, then let me have about 30 minutes more. Then let's move on to the decision-making part. So, in the program, there are three basic program structures. The first one is sequence. Sequence, actually you already demonstrate this sequence a lot. The computer reads your code from top to bottom. So, and then left to right. So in this code, you will execute, for example, you will follow this sequence. You will execute line 8 first, and then 9, 10, 11, 12, 13, one by one, from top to bottom. So this is the sequence. Then next, selection. Sometimes you will ask certain condition, and depending on that condition, you will do certain action A, or you will choose to do action B, something like that. So this is called as decision making. And the next one, the last one, repetition. Yeah, actually I emphasize that computer is not very smart, but it is very good at repeated job, right? So you already found that it generates the 100 random number very quickly, right? So we want to do some repetition using the loop, right? Okay, then among these three, you're going to learn about the decision making, selection. So to have this decision making, first of all, you need arithmetic operations. And then you will learn about the if, else structure. So this is the syntax of the C language. And also you will learn another function switch, but probably this will be covered in the next week. Okay, for the arithmetic operations, first of all, you can have the true or false, 1 or 0. So you learned about the is alpha function, right? If the input is alphabet, it gives true value 1. Otherwise, it gives 0. So if it is true, you're going to execute certain operation. If it is 0, you will skip it. This is the selection process. Relational operator. A is larger than B. B is smaller than C, something like that. Or equal each other. And logical operator. So you can combine several conditions using AND, or. So let's talk about the relational operators. So I'd better give an example. Is exam mark greater than 80? So if your grade, the mark is larger than 80, then you will get A, something like that. If your mark is 70, then it is false. Then you will skip this action. So is getChar equals to enter value, changing line. Does this integer n lie in the interval of 0 and 10? So you want to check whether this integer n is in the desired range. So to evaluate it, you can consider these 6 operators, relational operators. Actually, these 4 operators are quite straightforward for you, right? Then, if you want to check whether they are equal each other, then you must use this equality operator, 2 equal sign. So notice that this is different from single equal sign. And if the opposite is exclamation mark in here. So this is the example. Now you have the real number x. Then x times x larger than or equals to 0. It is always true. Then this whole part returns value 1. So you can consider that this whole part as numeric number 1. So if x is negative 5, x square is larger than or equals to 0. Yes, it is true because this is 25. Then you will display 1 in here. Okay, then the other case, the expression x square is less than 0 has a value of %d. It is always false because the square value of the real value is always positive. Then this whole part is 0, so you will display 0 value in here. Okay, so now your x is negative 5, then you have x square is less than or equals to 0. Then if you run this program, then you will see this message. So the return value of this is 0. And if you switch this, x squared is larger than or equals to 0, then you will see return value 1. Okay, right here. Sometimes, to explain that, I'd better talk about the syntax. Oh, maybe not. Okay, then let me show you another example. Now, A is 15. A is 15, then you have this statement. If parenthesis A, and then printf value of A. If you have if function, then inside of the parenthesis is non-zero value, you will execute the next statement. Otherwise, you will skip it. Okay, then what is the value of A now? 15, right? It is not 0, which is true, so you will display value of A. Then I want to explain about these two different signs, equality operator and assignment operator. if you have equality operator, 2 equal sign, it returns 0 or 1 after evaluation whether 2 operands are equal or not. But if you have assignment operator, it assigned the value from B to A. Okay, now A equals 1, B equals 5. Then you have a printf function. You want to display value of A equal B. Then you have this operation. Then eventually you will display 0 value because A is not equal to B. What about this? Now you have A equals B. Then this B5 is assigned to A, and then you will display value of A. So you will display 5. Okay, then if you have an assignment operator, and then you have an integer A is 2, B is 3, in the memory you store 2 and 3 in A and B respectively. And then you have this assignment, A equals A plus B, then A becomes 5, B is still 3. Now you have a relational operator, equality operator. A equals A equal B. So what is the return value of this operation? It is compared whether they are equal or not. 2 and 3 are different, so the return value is 0. So in the memory of the A, you will have 0 returned from this operation. Okay, then now you write this statement. Actually, this is not recommended, but just for the practice. Now you have if A equals 15, then do you think you can execute this? Yes, because now A has 15. 15 is not 0. So it is considered as true, so you will execute this, and eventually you will display 15. Okay, then let's see. We have a good example. Now we have this code. We have an integer A, which is 15. Then there is an if-else structure. In F, we just have A. Then if you run this code, you will display A is 15. You executed line 10 because A is true value. But if you have A equals 0, okay, then instead of this, let's try this. Now, you have 0 value directly inside of this if function. Then, you will not execute line 10 because this is always false. So you will display false message. this one, line 12. Okay, then inside of this part, let's say a equals 0, then we'd better try the right case. A equals 0. Actually, this is not true because a is 15. Then you will execute force. As you can see here. Then what if you delete this equal sign? Yeah, actually this IDE notify this is not right, but code may work, but it just gives the warning sign. It gives the force. So it executes line 12. But this is the not recommended syntax. Okay, next. Okay, so let me give you another example of the isDigit function. Coming back to this code. So you can say if now we have the declaration of the variable ch and the input is the assigned value is letter 1, which is digit. Then if isDigit ch is not 0, so since the input is digit number, this function will return 1. 1 is not 0, which is true, so you will execute this. But instead of using this comparison, you can directly use this function, isDigit, because this function already returns 1 or 0, right? Okay, so you can have the same result in here. Oh, why is there error? Can you see? This is very common mistake. I forgot to load header file. All right, now it's working well. Okay, so you can display 1 is digit and 1 is digit. The first sentence is from here. Second sentence is from here. So they are working in the same way. If you change ch to alphabet, then you will have the false message. G is not a digit. G is not a digit. So you execute it, else part, line 12 and line 17. Okay, so you can also have the comparison of the characters using the relational operators. Yeah, it's quite odd, but remember again, these letters has assigned integer value from the ASCII table. So if you have this relational operator for the letters, then it is actually comparing the integer value of it. And obviously, this uppercase B is integer value rather than integer value of uppercase A. Do you remember the integer value of uppercase A? 65. Uppercase B is 66 rather than A. What about this one? Actually, I don't remember the integer value of the letter 1. Okay, so 9. 9 is 57, 0 is 48. So it is larger. Uppercase B is larger than uppercase A. Uppercase is 65, lowercase a is 97. 32 difference. So it is true. I don't know this symbol, but it's like it is false. So you can have such a comparison considering ASCII value. Next, logical operator and or not. So you can use to and symbol, to bar symbol. This is or, and exclamation mark is not. So if the operand is 1, then it is turned to 0 by this exclamation mark. If the input is 0, it is turned to 1. Okay, so this and or are binary operators. So there are two operander, and then it is located between them. Exclamation mark is unary. It requires only one expression. So this is example. Temperature is larger than 90, and humidity is larger than 0.9. So to make it true, you have to satisfy to both conditions at the same time. And then next, x is larger than equals to 1, or x is less than 0. As long as you satisfy one of condition, it becomes true. What about this? X is larger than or equals to 1, x is less than 0. And is it possible to make it true? X is larger than 1, less than 0. It is impossible. So this is always false. Okay, then this is the example of exclamation mark. Not. So now x is larger than or equals to 1 and x is less than 0. This is always false, which is 0. Now you have a not. So 0 is turned to 1. So this is the true value table. Let's say we have the expression P and Q. And we have a P and Q, P or Q, and not opposite P. So if they are all false, they are false. P and Q are false, P or Q are false. And opposite P is true. As long as one of them is true, P or Q gives the true symbol. Right? And P and Q are false. To make it true, both expressions should be true. Okay, then let me give you one example. So now we have an expression even equals n%2 equals to 0. Which means if n is even number, then actually n%2 is 0, right? If it is even number. Then 0 equals to 0, which is true, then it will return 1. So, if n is even number, variable even will be 1. Otherwise, it's going to be 0. So example, n is 3, remainder is 1. 1 equals to 0, which is not true, so it will return 0. So even has 0 value. If n is 4, n% 2 is 0. 0 equals to 0 is true, 1. So even will have 1. So this is one of useful case using this logical expression. So you want to define the valid range of the numbers. For example, in here, we want to check whether number is between -10 to n5. So we need two conditions. So in the common mathematical expression, you may want to say n is larger than -10 and less than 5, like this. But this is not valid in C language. So you have to separate two conditions. Larger than -10, less than 5. How? So first condition is n is larger than -10, like this. Next, n is less than 5. And then you have to use AND, because you have to satisfy these two conditions altogether. Right? For example, your n is 10. It satisfies first condition, larger than -10. But does it satisfy second condition? No. Then it has to be false, not true. Because we want to confine range between these two numbers. So that's why you have to use AND. Then how can you express it? n larger than -10 and n less than 5. So this is how you can define number range. Use AND symbol. Okay, you can also check whether the input letter is alphabet or not. So we know the integer value of the letters. Uppercase A is 65, uppercase G is 90, lowercase a is 97, lowercase g is 122. Okay, then we want the input letter is within these two range, right? To make it true. So first condition is uppercase A. So this input value CH is larger than or equals to uppercase A. You can also say 65. And then next range is here. And CH is less than or equals to uppercase G. We have another range for the lower case, right? So we have CH is larger than or equals to lowercase a, and CH is less than or equals to lowercase g. The last question is whether we can use or and for these two range. As long as you satisfy one of these two range, it is true, right? You don't have to satisfy both range. Actually, it is impossible. So that's why you have to use or, as you can see here. So this is how you can define these two, the range of the alphabet. All right, so that's for the operators. And then, okay, now it's 9:30. Next week, I'm going to talk about the syntax of the if, else, and also switch. And then I'll talk about the loop as well. So I believe the next week contents will be the most important part in this C programming. As long as you are good at decision making and loop, you can make most of the program in this course. All right, that's all for today. Thank you for your participation. See you next week. Okay. Good night. Do you have any question? No?